Assalamualaikum and hi everyone. My name is Nurin and I'm going to present to you about the introduction of water resources. Water is the name of the liquid state of H2O. Water is an inorganic, transparent, tasteless, odorless and nearly colorless chemical substance. Water covers 71% of the Earth's surface, mostly in sea and oceans. Water plays an important role in the world economy. Approximately 70% of the fresh water used by humans goes to agriculture. Every year on 22nd March, there will be an event called International World Water Day. International World Water Day is an event that highlights the importance of fresh water and advocates the sustainable management of fresh water resources. This is related to water resources, demand, climate, and sustainability. World Water Day is celebrating waters and raise awareness of the 2.2 billion people who living without access of safe water. Water is under extreme threat of a growing population, increasing demands of agriculture and industry, and the worsening impact of climate change. As societies balance the demands on water resources, many people's interests are not being taken into account. This year, 2021, theme World Water Day is about what water means to people, its truth, and how we can better protect the vital resources. The value of water is about how much that is priced. Water has an enormous and complex value for our household, culture, health, education, economy, and the integrity of our natural environment. According to worldwaterday.org, adapting to the water effect of climate change will protect health and save lives, and using water more efficiently will reduce greenhouse gases. With the growing awareness of the urgency of water conservation around the world, the various stakeholders in Malaysia are urgently working together to fix a broken water system. Even though Malaysia are blessed with plentiful resources and abundant rainfall, Malaysia's water system is plagued with intermittent shutdowns, an aging system that desperately needs a new update. Water companies which are solely profit-oriented and public that is seeming unaware of the serious needs of water conservation. As engineers, we have to work together in order to achieve the Sustainable Development Goal, which is water and sanitation to all by 2030. Not only that, we also want to supply the clean and safe water to all the people without left anyone behind.
Okay, hi, Assalamualaikum. My name is Tengku Nagaranisa and today I will present about cover story. Okay, so rainfall is seasonal and rain does not fall evenly throughout the country. The result of typical rainfall characteristic as well as other climatic and physical factors which govern rainfall pattern. Okay, so Malaysia gets an average rainfall of 2.94 milliliters per year. About 43% of that return to the atmosphere through evaporation, 6% percolates into the ground, and the remaining 51% flow away as surface runoff. Okay, basically, agriculture industry is the largest user of water, requiring up to 68% of total water consumption for paddy irrigation, other crops, livestock, and fisheries. So, lack of reserve water is the most important concern in most states. Each state must have a reserve margin of between 8% and 12% in order for the system to function efficiently. We can have more than 15% reserve water if the system is well planned and managed. Unfortunately, our reserve is currently less than 2%, okay, which is it is critical because when the shutdown occurring, okay, and thousands of households have to go without water. Actually, we don't have a shortage of water problem, but we neglected the to upgrade the system. Okay, so however, with a reserve of at least 50%, majority of the household can have water supply for 40 to 70 hours in the event of the shutdown. One of the most persistent issue in the local water system is non-revenue water. Non-revenue water is water that is pumped or produced but subsequently lost or otherwise unaccounted for in the system before it reaches the consumer. Okay, so non-revenue water level are very high with the national average at 35%. We can call non-revenue water as a disease. For example, in Kedah, the daily output is 1480 million milliliters, okay, but 40% of that is non-revenue water. So, it means that over half of the water produced is wasted. Malaysia has developed a water demand management, okay, WDM. So WDM is to ensure more efficient and long-term water consumption. It's focused on reducing non-revenue water, using water-saving equipment, utilizing alternate water resources, and conducting a water audit for large water users. Okay, so actually we should be using 170 until 180 milliliters daily, but each individual use 220 until 230 milliliters per day. Malaysia is also exploring at alternative water sources supply. Okay, so right now, they are looking at all possibilities from rainwater harvesting and storm water storage to off-river storage and coastal reservoir. Okay, so all of this can be planned, okay, but we need the resources, okay, to do it, as well as enough water to run down the rivers as storage before we can figure out how to transform it into drinking water, okay, industrial water and agriculture water. Okay, so actually we have the technology to find the underground water, but the technology is changing all the time. So the engineer are always need to keeping up to date. Okay. Malaysia is looking to countries that are already dealing with the underground water. We have the 4D technologies from Japan to help with the mapping of subterranean rivers. To protect the water resources, okay, the introduction and application of total maximum daily load for each river basin is obligatory. Okay, so what is TMDL? Okay, so TMDL is computation that determine the maximum amount of pollutant that can enter a water body in order for it to satisfy and maintain water quality criteria for that pollutant. Okay, so actually, total maximum daily load is still new in Malaysia, but it has been practiced in the most developed countries such as United States, okay, United States of America, in the management India, okay, in the management of water bodies. Okay, so overall, we want engineers and planners to keep up with the latest technologies, which they need to advise the federal and state water department on the right technologies to use.
Assalamualaikum warahmatullahi wabarakatuh. Today, I want to present about why we need better flood forecasting system. We need a better flood forecasting system because in Malaysia, flooding is the most natural disaster, and it affects 18% of the country annually. There have been record of major flood, as we know, 1926 for the whole country, 1963 in Sarawak, 1970 Kelantan, and every state uh, have been affected by flood. Okay, so the Permanent Flood Control Commission was established by the government to investigate long-term flood mitigation method. One of its responsibility is set up rainfall and water level station to monitor and transmit data as fast as possible to obtain flood forecast. The flood forecasting model has made major progress by combining complex and people-oriented model to achieve better and more accurate flood forecasts. Thanks to the latest technology in rainfall forecasting and increased accuracy of surface topography data. Flood devastated Kelantan, Terengganu and Pahang in December 2014, executing nearly 500,000 people and losing about 2.85 billion, not including intangible losses. There are dissatisfaction about flood forecasting system, which is delay in early flood warning, especially for upstream areas such as Kuala Krai and Kuala Tahan, particularly during the second wave of flooding. Second, delay in evacuation response for rescue and location of flood victim and evacuation center. And lastly, shortage of flood relief assistance such as closing food, medicine, and evacuation center. By establishing the National Disaster Management Agency, the government took the initiative to strengthen the institutional framework, which is NEDMA. NEDMA greatly enhanced agency coordination, allowing for more comprehensive flood relief and response. And the DID, which is the Department of Irrigation and Drainage, and MMD, Malaysian Meteorology Department, collaborate on a new flood forecasting project called the National Flood Forecasting and Warning Program to strengthen the system, which is PRAP, Program Ramalan, dan Amaran Banjir Negara, because the existing flood forecasting and warning system has limitation in terms of forecast allocation, lead time, and flood warning coverage. The notion of PRAP was proposed to get better flood forecasting. There are current flood forecasting system. The first telemetry water level station established at the Sulaiman Bridge on the Klang River. Second, the number of rainfall and water level telemetry sessions has increased tremendously, seen from less than 20 to 800 stations currently. In situ flood siren warning system has been established in areas affected by frequent flooding, mainly to provide early alert of rising flood water. And in Malaysia, the first mathematical model called Scaramento model, established in 1973, was used to estimate water level at Sungai Pahang. Since 1981, the Sugawara Tank model was used at the Kelantan River with very reliable forecast. And the main objective of the PRAP to develop a system which can forecast monsoon flood 7 days in advance based on weather forecast data from the Malaysia Meteorology Department to increase the capacity of the existing system for warning and dissemination of information about monsoon flood from 6 hours to 2 days early for the benefit of related agency and population affected by the flood. There are a few components to be implemented in an integrated manner using the latest technology, which is hydrological data detection system, database and ICT infrastructure system, flood modeling and forecasting system, flood warning and dissemination system. And there are a platform of website that is Info Banjir that presenting and spreading real-time flood information to the public. The website was launched in 2000. It's constantly be updated to match current expectation and to accommodate new technology. Prague website will be enhanced with the addition of two additional features. The first step is to create a more informative and accessible user interface. Rainfall and water level statistics are displayed in a simple and accurate manner on the web. The second component is to include an early flood warning message from agency with a 7-day flood forecast and 2-day flood forecast for the public. Other technique for communication forecast information include control flood siren and for our information, from 2015 through 2025, the Prague program will be conducted into phase 1 and phase 2. Sungai Kelantan, Sungai Terengganu and Sungai Pahang are the three primary river basin where phase 1 has been executed. Phase 2 began in 2018 and is anticipated to be finished by 2025. Flood forecasting model and additional hydrological monitoring station will be installed in 38 river basins across the peninsula, Sabah and Sarawak. Transformation and advanced technology. There are 4 elements in the transformation plan by Prague. Early flood forecast duration. The system will improve the advanced flood forecast from 1 day to 7 days. Second, early flood warning duration. The system will improve the advanced flood warning from 6 hours to 2 days. Enhanced flood warning database system. The database system is a key component of Prague, as all components will integrate with the forecast data center server as the central data system. And second is wider the coverage for the flood dissemination. There are some issues and challenges in implementation of Prague. First, one of the challenges is to have locally created item with locally sourced material and local professional innovating. Second, a flood forecast model developed in the United Kingdom, UK, has been used by Prague, allocating at a set number of financial resources to license and technical assistance will result in considerable long-term loss. However, developing our own flood model is difficult because according to the existing model developer, it takes a great deal of experience and a long period of development. It takes about 20 to 40 years to develop it. Third, almost every month, flash flood occur over a relative brief period of time, 1 to 6 hours. In addition, the affected areas are small. As a result, a flash flood early warning system is required, and state-of-the-art technology using radar and satellite can be investigated. And lastly, the current delivery method should be upgraded to reflect effective stakeholder interaction, which will aid the understanding of the issue of flood forecasting transmission of more target to the public information. Okay, that's all from me for the flood forecasting. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Maizatul. I'm going to present for forums part. This is the table of contents. There is 4 forums in the article, which is biomedical engineering, a career path with a bright future. The second one is underground tunneling in Klang Valley, the pursuit of autonomous tunnel boring machine. The third one is head type steel sheet pile technology for improvement of construction productivity. And the last one is the way forward for SMEs in Industry 4.0. For the first forum, the speaker shares about biomedical engineering. Biomedical engineering is a science, technology, engineering, and mathematics career path with a bright future. The government has been encouraging STEM even in primary school, as it has implications on workforce development, national security concerns, and immigration policies. Applications of engineering principles and design concepts to medicine and biology for healthcare purpose. Biomedical engineering can work in research and development activities focusing on the next generation products, innovation, and strategic planning. The second forum is underground tunneling in the Klang Valley, talk by IR Nantakumar. 60 participants has attended a technical talk on the underground tunneling in the Klang Valley. IR Nantakumar presented the general scope of design works on the KVMRT project at Malakoff Auditorium. He discussed the various geologies in construction method used as well as the tunnel interface procedures, highlighted the various risks associated with tunneling. Autonomous TBM has developed during the second MRT line to minimize reliance on TBM operators. The effort of the teams have won them 2 awards. The third forum are about head type steel sheet pile technology. The Civil and Structural Engineering Technical Division hosted an evening discussion on head type steel sheet pile technology for improving construction productivity in Malaysia, and invited Dr. Kazutaka Otsushi to be the speaker. He is in charge of research and development, market development in Asia, and technical support of steel sheet pile technology, design and construction in Singapore. Dr. Kazutaka Otsushi speak about the introduction of head type steel sheets, the reduction factors for ERSS designs, the actual scale field tests, and track records of head type sheet pile and installation method. The last forum is about the way forward for SMEs in Industry 4.0. Building the Industry 4.0 ecosystem is a huge challenge because of the scale and complexity of converged networks and joint developments in the platforms. Government, technology companies, trade unions, and academia are required to work together to build the Industry 4.0 ecosystem. New framework and connectivity standard need to be defined and developed for each layer of the structure in order to implement an affordable industry for the SMEs in the supply chain. Okay, that is all from me. Just remember, the road to success is under construction. Bye-bye.
News from branch. IEM Melaka technical visit to Kota Kinabalu. On 21st to 24 November 2019, with 12 participants, they go to visit Sungai Mayong Flood Mitigation Project, RTB, Sungai Mayong, which is a federal government funded project implemented by the Department of Irrigation and Drainage DID through DID Sabah Supervision Team. They also pay a visit to Danish Hydraulic Institution, DHI, Environment and Water Sdn Bhd. DHI is an international environment and water consultant specializing in numerical modeling and simulation of water-related engineering solutions. Lastly, they visit Kampung Tempasa at Penampung to view the gravity fed system, local water supply, and brief on plan to consult a mini hydro. Next, we have a news about technical visit to Favel Fafco Cranes. The Institute of Engineers Malaysia Negeri Sembilan branch, IEMNS, organized on 14 November 2019 with 26 participants to visit a Favel Fafco crane in Senawang, Seremban. The factory occupied a land size of 68,846 square meter. It manufactures tailor-made crane such as construction tower crane, offshore crane, and wharf cranes. Engineering Manager Mr. Teo Han Fui give brief explanation on the crane design flow. The fiber vacuum testing yard can handle 8 test units of crane simultaneously. For crane design flow, the first step is client specifications are reviewed and design parameters are identified. Next, engineering analysis on the crane to determine the load chart, component sizing, and which selection is performed. Step 3, designing the mechanical and electrical system. Step 4, the finalized design is submitted to the client for review and response for comment. Step 5, the endorsed crane design is handed over to the production flow where various machines such as lathe machine, flange cutter, rolling machine, laser cutter and welding machine are used. And lastly, testing of the crane. Next is the campus news. The Nano Satellite UITM SAT-2 Mission Idea Symposium. 14 members of IEM and FKE student section of UITM Shah Alam visited Kyushu Institution of Technology Kyushu, QTech in Japan on 21st to 26 January 2019. The students have prepared 4 missions for this program. Firstly is AIS, Automatic Identification System, is an automatic tracking system for locating the whereabouts of sea-going vessel. Next is SNF, which allows the collecting of data in certain area. Periodically, of these are sent to ground control for analysis. EDS is used to detect stormy weather and to provide alert as a defensive step against natural disaster. Satellite camera enables the capturing of wider image from space, especially of places that may otherwise be inaccessible. Next is engineers' adventures. Mark beauty of Dal Lake, Kashmir. Dal Lake is a tourist attraction and heavily polluted today. Dal Lake has been called Lake of Flowers and Jewels in the crown of Kashmir. The lake once covered an area of 35 square feet kilometer but has shrunk to 12 square feet kilometer in the last 2 decades. Srinagar's Lake and Waterway Development Authorities LWDA estimate 50 mld of sewage are discharged daily into the lake, of which 20 million litres are untreated. In May 2019, the government stopped further registration of houseboats.
In a conclusion, water resources play an important role to keep people, animals, plants, and other living things to keep alive. Water resources is playing a big role in order to supply, treatment, and usage of all important sectors in the world. They are including agriculture sector, industrial sector, and many more. Actually, water is the most easier sources that can be accessed. There are many sources that we can have water, such as groundwater, stormwater, and also wastewater. Water also can be gained from rainfall. In order to appreciate the importance of water and the management of water, so we have to celebrate World Water Day on 22 March every year. This event is established since 1993. As I mentioned before, this event is to appreciate the importance of fresh water and advocate for sustainable management of freshwater resources. Do you know there are many diseases and deaths caused of water? To avoid from the increasing of disease and death, we have to take care of water resources in our nation, and also we have to bring it to the outside, to the world, so we can help each other in order to have a good management in water resources. In Malaysia, we have to update the system of water resources and water treatment to improve the reservation of water resources in Malaysia. Flood also can cause water pollution. To avoid this natural disaster happen, we need to have a better flood forecasting system. So, in this system, we can manage the water and can avoid the flood from happen in our nation. Our government has established a permanent flood control commission to investigate long-term flood investigation methods. So, delay in early flood warning is a system that have a failure. So, this situation need to be fixed, especially in upstream areas, to avoid any flood happen in the area. Actually, this is a part of the system that government had to do, because sometimes flood cannot be controlled anymore. Last but not least, everyone needs to work together in improving the water resources management system in our world, in our nation, and also to help our world to achieve the Sustainability Development Goal, which is water and sanitation for all by 2030. Not only that, by that, we can help other 2.2 billion people that cannot access to safe and clean water to have and get their clean and safe water to be used in their daily life.